In part 3, let me explain the guidelines for selecting a shaker that is able to carry out the tests from the testing conditions given. First, the result of 5 kN is acquired for a maximum rated force by multiplying the mass of 50 kg and the acceleration of 100 meter per square second together. Next, velocity is determined by dividing acceleration of 2pf. Accordingly, 1.41 meter per second is acquired for velocity by dividing 100 by a value acquired from 2p multiplied by the frequency of 11.25. Next, let me explain a method of selecting a shaker for the random wave test. Although it is a little complicated as compared with the sine wave test, the way of approach is the same. In other words, let's confirm whether or not the rated force, velocity and displacement satisfy the specification. However, note that a root mean square value is specified as the testing condition for the random wave test. Next, let me explain the method for selecting a shaker for the shock wave test. As for the shock wave, the way of approach is the same, that is, the confirmation is made whether or not a rated force, velocity and displacement satisfy the specification. First, let me explain the case of a half sine wave. An acceleration graph is on the leftmost side in the slide. The velocity graph in the center is acquired by integrating the acceleration in time. The displacement graph on the right side is acquired by integrating the velocity in time once again. Please pay attention to the portion enclosed by the red circle on the right side in the velocity graph. Next, let me explain an SOR test, a test in which the sine wave test and the random wave test are joined together is referred to as an SOR test. Let us confirm whether the square root of a sum of the RMS value squared to the sine wave and the RMS value squared of the random wave is equal to or less than a random rated RMS value or a rated force of the shaker. Furthermore, let us confirm whether a maximum value of a sum of a sine wave and a random wave is equal to or less than a sine wave rated peak value of a rated force of the shaker. To the velocity, let us confirm whether the maximum value of a sum of a sine wave and a random wave is equal to or less than the sine wave rated peak value of a rated force of the shaker.